Okay, this is a continuation of section 2.1 for MAC 1105. We had just begun to answer questions regarding equations and whether or not those equations define y as a function of x, and decided that the graph was the best way to tell that. When you don't have a list of points where you can check the x and the y values, a graph would serve the same purpose, but what you would be performing is the vertical line test in order to make sure that for each x value there is only one unique y partner. So we were in the process of putting this in the graphing calculator, but to do that you need to solve for y. So we had moved the x over to where the 8 is, giving us 8 minus x, and we're about to remove the cube. So the inverse of cubing a term is to take the cube root. And so we have to make that same move on the other side, take the cube root of the expression. There is no plus or minus, that's only for even roots. And because this index is odd, you just have one root. So you don't need to enter it in the calculator in pieces as you do some graphs. So the cube root of y cubed gives you just y, just as we want. It has to be like that if you're going to put it in the calculator, and then we're going to do cube root of 8 minus x. We're going to try and get that graph using the graphing calculator. So let's take a look at where that key is. If you don't already know this, there are pre-made keys concerning square roots as well as cube roots. If you're going to go any higher than a cube root, like 4th root, 5th root, then you have to tell your calculator first what kind of root it is. You'd have to feed in the index first. This is the index. So if this was 4th or 5th, you would put the 4 in first. Then you would call up a generic root that's found under the math key. So let's just look at the math key to see what's available. So you see that on this key there is the cube root is already offered, but then nothing higher than that. So if you were going to go higher, you would use this generic root key. And you would tell it that number first, and then you would use this key for 4th root, 5th root, and anything higher. But we just need the cube root, so let's think about how we're going to get this to appear as part of a graph. You know that first you would go to y is equal to, clear out whatever is there. Then we want to call up the cube root symbol, which, as we just discussed, is under the math key. So press that, go down and select option 4, cube root, and feed in whatever was underneath the radical symbol, which is called the radicand. So 8 minus x was underneath. Close that parenthesis, press enter. If you want to use pre-made graphing windows, those are under the zoom key. Zoom standard is a nice window, but you will quickly be able to see whether or not that fits the particular graph that you're trying to show on your window. So let's see if we do pick that, what happens. And then we can talk about adjust. Okay, so quite a bit over to the right of the graph is cut off, so we definitely need more x max. This is called x min over on the negative side, x max on the positive side. Likewise, when you're talking about the y-axis, we really don't need as many numbers here, and we might as well, take a couple of minutes to discuss adjusting the window so that we can see more of what we're trying to see. Not that this is not good enough, but you're not familiar enough with the graphs to know whether parts are missing. So since nothing's going on up here and nothing's going on down here, we can give ourselves much less of a y max and a y min. And as far as the x max goes, we need more of that. So less on the y-axis, more on that positive x-axis. So let's talk about window. Zoom is where the pre-made windows are. So we just pushed standard window. That's a negative 10 by 10 on the x and a negative 10 by 10 on the y. And we're going to adjust that. When you want to adjust manually, you will push window. And we said that we could use a lot more x max. So how about, let's go to 20 and a lot less on the y-axis. So on the y-axis, let's say we only go to negative 5 maybe. On the y min, and on the y max we'll do the same, just to get a better view of what the picture looks like. Okay, so that's a much nicer view of what the picture looks like. We've adjusted according to the shape that we're graphing. This cuts right in at 8, and then it curves up to the left and down to the right. So now our graphing grid that we have to graph doesn't go all the way to 8, so we can just kind of improvise. We'll put the 8 right here, showing that it has an intercept there, and then according to our graphing calculator went like this basically, and then curled and went that way. For purposes of answering this type of question, does this equation define y as a function of x? That's the same thing as saying, does it pass the vertical line test? Okay, and you can see that no matter where you pass this vertical line, any vertical line is only going to make contact with the graph once, whether you pass it here, whether you pass it here, whether you pass it here. It's only going to pass through it once. That is not a piece that goes completely straight down, just in case you're thinking that. It has a curve, and so the vertical line would pass there as well. So, yes, this passes the vertical line test. We checked that out already, and that means that this equation defines y as a function of x. Or put another way, yes, this equation is a function. Okay, so just the wording that you should get used to. Moving on from that, does the equation y equal to square root of x plus 4 define y as a function of x? Again, you can look to the graph to answer that question. It has to pass the vertical line test, because the vertical line test shows that any x on the graph, any x coordinate, has one and only one y partner. It has a unique y partner. That's what you're proving, which is actually the definition of what a function is. It's just that you're proving it by means of a graph. So now this is already solved for y, so it's ready to go, ready to be put in the calculator. We do have a button on the calculator where that's already there, so we don't have to get crazy or creative with that. We get rid of that. So we're going to press square root. That is a second function, so press the orange key right there, and then look for the square root symbol. So second square root, and then you're putting whatever was underneath the square root, which was x plus 4. The radicand, that's called. Okay, we can try as a standard window, and if it doesn't work, we can adjust manually. Now in this particular case, this standard window gives us a fine picture, and we can see that it cuts right in at 4, at -4 actually. They actually, they're going to, has to do with this radicand right here. If you set this radicand equal to 0 and then solve it as an equation, you can tell what the x-intercept is going to be. Same thing for this. This had cut in at +8, and if you had set 8 minus x equal to 0 and solved it, you would get +8, that x-intercept. But anyway, the calculator gave that to us. You could see that it cuts in at -4, which would be the solution if you set that equal to 0 and solved it. So we're going to go right in here at -4, and the graph is like that. We don't have to get too detailed because, again, all you're trying to do is pass a vertical line through the picture that you are supplying, showing that you know how to create a graph from your calculator for purposes of what we're doing right now. That's fine to do. No matter where you pass a vertical line, it passes. So, passes the vertical line test. And therefore, these 3 dots shaped like a triangle stand for the word therefore in mathematics. It passes the vertical line test. Therefore, the equation is a function in terms of x. It's just a specific type of wording that you can use that means the same as this. Okay, then using graphs to evaluate functions. You have done quite a bit of evaluating functions, but you've done it algebraically. Like someone will give you a function that says f of x is equal to x squared plus 5. And if they ask you to go and evaluate the function, you just plug the number in and see what it turns out to be equal to after performing the operations that the function suggests. That's how to do an evaluation algebraically. Here you're doing it graphically. So in this problem, notice that at the bottom it says, what is the function f evaluated at -4? So in this particular problem, when they're saying what is the function evaluated at -4, you know that functions are usually read f of x. So what they're telling you is what the x value is, and they're waiting for you to find what the y partner is that's associated with this x value. So x is -4, and we want to, an evaluation means for the y partner, but we're not doing it algebraically. So basically all you do is slide to the value that they give you first, right here, move either up or down until you hit the graph. Okay, so I come here, I had to move up to hit the graph, and when I do hit the graph, if I want to know the wire that's associated with this point where I'm making contact with the graph, all I have to do is slide my vision over to the y-axis. You will always move your vision over to the axis, the coordinate that you're looking for. We're looking for y, so I look over to the y-axis, and it is 3. So I've evaluated at -4. I've also been asked to evaluate at 3. Again, use whatever is in this parenthesis stands for x, so you've been given the x value, and they want to know what is the y partner. You've given the x value, what is the y partner? So you should like these because they're very little work. Just slide over to the given x value, move either up or down, whatever needs to be done to make contact with that graph, and at the point where you make contact, move to the axis that you have not yet been on, which is the y-axis. Because I started off this problem by sliding over along the x-axis. So I've already been on the x-axis. Now I want to make my way to the y-axis from that point of contact. And I am at +4. Okay? So the answer was 3 in this case, 4 in this case. Likewise, you have the same type of problem down below. In the graph down below, you've simply been asked for one value, and that is, what is the function, the f that you see here when they ask these questions? That's just the name of this function. And they're supplying you with a graph for the function called f. This function also happens to be called f, and they've supplied you with a graph that represents it. So when you're asked what is the function called f, what is it equal to when we evaluate it at -4? Again, this is usually read f of x, so therefore this stands for the x they want you to start the problem with. So slide to -4, and I would say to make your way to the graph at that point, just as we did in the 2 examples above. But the minute you slide to -4, you're already on the graph, so you don't have to make your way to the graph. So you're already on the graph, and the very next thing that there would be to do is to identify what is the y partner that goes with this x value. So remember, you're always going to start by sliding along one of the axes. Since they've given you x, that was the axis that you slid out on. You slid to -4. You want to know the y partner. So at some point, you have to get your vision to slide back to the y-axis to see what that number is that's associated with this point of contact, which is 0 in this case. So our answer for this example, 0. Okay, moving to the next page, where we were looking at problems that tie everything together in this section. On the first couple of pages, we talked about domain and range by looking at a set, a relation, a set of ordered pairs, and the x's were the first coordinate in each pair, and the y was the second coordinate in each pair. We also looked at graphs and talked about domain and range. We also have talked about the x-intercept. That is the point or several points where the graph hits the x-axis. It's specifically the x-coordinate at those points. There were also some examples in this section that we've already done where we talked about the y-intercept, which is where the graph hits the y-axis, the y-coordinate of that point. And then we just finished on the previous page doing these kind of problems where we would take the function, the graph that's given for a particular function, and evaluate it at specific numbers. So again, these problems that we're on now tie everything together. So in this first problem right here, let's go over the various things that we've talked about. Domain. Remember that domain, those are the x values. So when they give you a graph and they don't list specific x values, you want to know basically what is the width of the graph. From what x value to what x value does this graph stretch? And you can see that in this particular graph, it stretches from -5 on the negative x side all the way to positive side. And it cuts off there and it cuts off there. So the domain, if you give it in interval form, is -5 to 5. And I'm using brackets around these endpoints, -5 and 5, because these endpoints are colored in. Sometimes it's going to show that it goes into infinity instead of stopping bluntly at a particular point, and then you will use infinity symbols to show that it goes on and on. Sometimes that endpoint will be colored in and you'll use a parenthesis instead of a bracket. Okay, stating the range. The range happens to be the y values. So when you're doing the y values, you basically want to know how high are you going and how low are you going. I know that's not how you spell high, just finding a short way to write it. How high and how low are you going? Just a very explaining what range is. So the y values we're interested in now. So this graph goes as low as -4, but as high as +4. It actually has a solid point right there, although they didn't color in the dot because it's part of this continuous graph, and it actually has points right here. So this goes from -4 all the way to +4 for the range. X-intercept, you just want to see where does it hit the x-axis. This particular graph hits the x-axis in various points, and you want to name the x-coordinates that go with those points. So the x-intercepts in this particular case would be -5, -3, -1, +1, anywhere that it hits the x-axis. +3 and +5. Those are all of your x-intercepts. Next is the y-intercept. Where does the graph hit the y-axis? Right at 4, and specifically when you're naming a y-intercept, you want to name the y-coordinate. The y-coordinate at that point is 4. Okay, last thing we're doing in this particular review problem for the section is evaluation problems. We're going to find out what is the value of the f function when x is 2. Okay, remember these are x values and you are simply looking for the y partner. So when you're evaluating the f function at -2, that means slide your pencil to -2, travel either up or down, whatever is required until you hit the graph. We have to go down. And when you make that point of contact, slide your vision to the y-axis. Because when you do, that value will be the y partner. This can also be written as a point, -2, -4, which is a point on that graph. Next, we're evaluating the function at an x value of 0. So put your finger on x equal to 0, move either up or down until you hit the graph. We have to move up. And when you make point of contact, you want to know what the y coordinate is. Now, we happen to be on the graph and also on the y-axis. That point of y contact has a y partner of 4. Again, you can write these as moving to f of 4. F of 4 means slide to x is equal to 4. You would have to move up to make contact with the graph. And when you make that point of contact with the graph, slide over until you find the corresponding y coordinate. which in this case was also 4. So we have 4, 4, and that is a review of all the concepts that were in this section mixed in one problem. There's another one like that below, which will be covered in the next video.